is prediction interval. The following are number of steps worked in each of the last 7 days: 600, 6,822, 5,333, and 7,420, 7,432, 62, 6,252, 7,005, 6,752. Assuming that the daily numbers of steps can be thought as begin independent realizations from normal distributions, give a prediction interval that 95% confidence will contain the number of steps that will be worked tomorrow. So friends, a sample calculation gives that the sample mean and sample variance of 7 data values. So friends, I have to find out this x bar 7. Okay, how can I find out? 682 plus 5 3 3 3 plus 7 4 20 plus 6252 plus 7005 plus 6752. This is the way I have to find out mean. So it is divided by 7. So this value, whatever I get, this value, friends, this value I get 66,716.57. Okay. Similarly, friends, I can find out the variance. Variance, how can I find out variance? S7. Variance formula is variance. How can we find out variance? Okay. Variance formula I apply in here. Variance formula is s square 7 summation xi minus x bar whole square divided by n minus 1. Okay, it is the number of observation and n minus 1. This is the variance formula. So how can I, this way you can find out variance, and this value will be 733. So that implies 733.97 is equal to S7. So friends, it is the back calculation how to find out standard deviations. Okay, standard deviations. So friends, the problem is based on T distributions, friends. T distribution. This is the test statistics. Test statistics is T distributions, friends. So independent realizations form a normal distributions. Okay, so it is T statistics is T statistics, and my T statistics is T 0.25, and number of degrees of freedom is 6 because n minus 1 equal to 6. That value is 2.447. Okay, this is the T table. You get this value from T table, friends, and 2.447, and my interval estimations estimation is interval estimations is t alpha by 2 and degrees of freedom n minus 1 into Sn root over 1 plus 1 by n. I apply this formula in here. So this formula if I apply, so this value 2.447 into 733.97 root over 1 plus 1 by 7. This value is 1920.23. So friends, so my interval is 6716.53 minus 1920.23 into 6716.53 plus, this is the 9, okay, this is not 4, this is 9, 1920.23. So this is my values, and my interval. So the question was that the interval, confidence interval is 47, after adding this value 479654 and 863.60. So friends, this is my confidence interval. Okay, now I will discuss theories. Theories are very, very important, friends, because theory, prediction interval. Suppose x1, xn, xn sample and normal distributions with unknown mean mu and unknown variance sigma square. Okay, here mean and mean and variance both are unknown. Okay, in this question you have seen this is the both are unknown, and x1 xn are to observed, and we want to use them to predict the xn plus 1. Okay, we want to get xn plus 1. So how can I find out? Okay, xn plus 1, in here you get, this is the interval, this interval we have to find out, and x8 belongs to this, because xn n is equal to x7. Okay, and xn plus 1 is equal to x8 in this case. So friends, to begin, note that if the mean mu were known, and it would be natural predictor xn plus 1, it is not known. It seems natural to use its current estimator is x1 plus xn, namely the average, and xn as the predicted value of xn plus 1. We should use the observed value is x bar n, the predicted xn plus 1. We want to determine an interval we predict and certain degree of confidence, and xn plus 1 will lie. And to obtain the prediction interval, note that the x bar n is x bar n is normal, and with mean mu and sigma square n xn plus n, which is normal with mean mu and variance and sigma square. Xn plus 1 x bar n is normal with mean 0. So this is the formula, xn plus 1 divided by x bar n, and is a standard normal random variable. Okay, so s sigma square, this is the n minus 1 degrees of freedom, because it follows from the same argument of the establish and replacing sigma by its estimated Sn and t random variable n minus 1 degrees of freedom, and I will discuss also t statistics. And t random variable n minus 1 degrees of freedom hence vary 0 comma 1 1 comma 2 1 1 by 2, and p t alpha by 2 comma n minus 1 is equal to, this is the value n 1 minus alpha, which is equivalent to, this value is equivalent to this, and hence it is observed that this is xn plus 1 belongs to xn bar and t alpha by 2. This is the, so friends, you see, same type of problem, this theory I apply in this question. Same type, I have to find out x8, this is the x8. Okay, so I hope it is clear for everyone. Thanks for watching.